click on videos, this is where we're going to post all the videos. Now, if you look here, there's an introductory video, and these are chapters. You can go through all those chapters of the book, and it'll show you different aspects of it. Like if we click on chapter 1, chapter 1, click on. Chapter 1 is not clicking. Let's click on chapter 2. But this is a different course. I don't know why this not work down there. Let's click on chapter 3. I'll have to go back and check that. Okay. Well, so it just goes through the lectures from chapter 3. And it goes through like the recordings that we've had. So any questions, it'll show other types of chemistry. You can go back and review all those if you want to. They're just for you to do. The questions from different students, and so you can get to those. But what's good? Okay, let me move that. Okay, so that's where you'll see where it says prep session. Yours will say 2022 prep session. These are all the different sessions, so that you'll be able to get at it. Okay, but this is where you're going to find it right at the bottom here. All right, so that's where those recordings are going to be. Now, if you click on modules, you'll have a whole chemistry class to go through. This is my forensic chemistry class that I taught a couple years back, and it's going to have everything. It has basic information, introduction, course objectives. This is my contact information. Okay, my school email, school phone number, office phone number, and the number you can text. Okay, feel free to use any of those to contact me. I don't mind at all. Use this email. Those two numbers aren't. You get me to the school. But the office phone is not that good anymore. I'll have to change that. But my text number, you can text me or email me with those two numbers. And if we go, like I said, go to modules. And there's something like here I put together for the student called a data packet. If you click on this will put all the data that you have for chemistry and other classes too, other math classes, biology classes. This all your conversions. Okay, it's all in one place here for you, easy to find. So here's your metric conversions, what each one means. Like milli is 10 to the -3, nano is 10 to the -9. If you don't understand those exponents yet, I'm going to go over those too. I'm going to go over exponents, scientific notation. We'll start with the very basics, go over everything for you. So a good background going in any math class, any biology, any chemistry class that you can take at the school. These are your English to metric conversions. In other words, 3.28 feet is 1 meter. 1/8 is 2.54 centimeters. And then common English conversions. 60 seconds is a minute, 32 fluid ounces is a quart, 12 inches is a foot, etc. Then with chemistry, we're going to get into things called polyatomic ions. Okay, polyatomic ions are just groups of ions with a charge. And this is where you're going to find them all right here in this chart. Like if you want what phosphate ion is, like hydrogen phosphate is what we put in Coca-Cola to give it its taste. That's PO4 with a -3. Okay, acetate. Acetate is vinegar. It's CH3 still with a negative charge. And again, these don't make much sense to you now, but they will as we get into it. Then this is a solubility chart. This tells you if you mix two things together, is a solid going to form, or is it going to stay both liquids? That's real helpful when we do some experiments that we do in chemistry labs. Pressure conversions, different atmospheres to different millimeters of mercury. If you're going to a nursing program, we use pressure for blood pressure all the time. 120 millimeters of mercury over 80 millimeters of mercury. Very common blood pressure. Here's some of the ideal gas laws. These are in organic chemistry. These are some of the prefixes. These are electronegativity values. This deals with protons and electrons. Like I said, we haven't gone over any of this yet, so I don't expect you to know all this. But it's just where you can find a lot of information. And you don't have to dig through manuals or anything else. Here's your common acids, common bases. This is your activity series, what's going to react with what when things are mixed. These are your specific heats, which is qualities of a compound, of an element. Organic nomenclature, this is the DNA code. For when we take DNA, goes to RNA, goes to amino acid, your protein. This is the DNA code. This tells you what triplet of your DNA code codes for each amino acid. There's 20 amino acids in the body, and they build every single protein, enzyme, everything in your body from those 20 amino acids. And here's the codes for it. It tells you the most common ones are here. Temperature conversions, degrees centigrade to Fahrenheit, degrees centigrade to Kelvin. Everybody has pet peeves. Okay, my pet peeve is see the K here, that's Kelvin. There's no degree there. Kelvin is not a temperature. It's a measurement of energy. So Kelvin never has a degree. If you put a degree, most teachers will mark it wrong. Okay, because Kelvin is a measurement of energy, but it converts to a temperature. At 0 Kelvin, all motion stops. So it's impossible to have a negative Kelvin. You'd have negative Fahrenheit, you'd have negative centigrade, can never have negative Kelvin. Because at 0 Kelvin, all motion stops and everything ceases to exist. Yeah, but you created a black hole. There is no more motion. Everything compresses, the Earth compresses to the size of a pinhead. Everything condenses because there's no movement of electrons. Everything's going to collapse. So you can never go 0 Kelvin. Other constants like speed of light, Planck's constant, we're going to use Avogadro's number, different formulas here. And this is, you have these to hand out in class, but this is a really, really good periodic table. This is one of the best ones called Flynn. You can go online, go to Google, type in Flynn if you want to get one bigger, and download the front and back of it. And this is all the information you need in chemistry. This is one of the best periodic tables I've found. And this tells you the elements. We'll go over what all this means too. But it's just your data packet. And you can print all this out. It's like 7 pages, or you just download to a PDF file, or if you need help with it, let me know. I can put a PDF file for you. Okay, but that is just so much easier if you know where everything is. You don't have to go searching for everything. So here's all your data you're going to need for chemistry. And again, it will help in all the science courses. Okay, what else do I have in my modules? So you know how to contact me. You know the data packet. Help with campus. Okay, there's every chapter here. Okay, chapter 1, 2, 3, I think it's 16 chapters. And it's going to tell you what each chapter is about. And you can review this, and this will help, especially if you not taking classes yet, you don't have a book, go through here. Chapter 1, foundations. Chapter 2, measurements. Chapter 3, atoms. And this is all that we're going to be doing on those first 3 chapters. And you don't need the book to do this. So here, click on, just start at the beginning. Remember, just go to modules, start with week 1. Click on chapter 1, foundations. Click on chapter 1, foundations. Hopefully this will do some, there we go. So this tells you, this is chapter 1 we'll cover. And this is all going to be on here. Okay, heterogeneous, homogeneous, things like that. And if you hit next, you go to chapter 2, measurements. And that'll tell you what all is involved in that. Next one's chapter 3. Most of it is one, the first 3 chapters are pretty straightforward. Okay, so those are reviews of each chapter, the overview of each chapter. Okay, and then there's solutions. These are different things that I went through and that I think are important for each chapter. So this tells you solutions, homogeneous and heterogeneous solutions. It tells you the difference and it gives you pictures. This is a homogeneous solution. No matter where I draw that circle, it's going to be the same. This is a heterogeneous solution, like vinegar and oil. Okay, no matter where, if I could draw the circle, and it's to be different at different places where I draw it. That's called heterogeneous. Okay, so it just shows you different solutions. Okay, significant figures. We're gonna go over that a lot because that's you need that for any science class you take. And this is a whole lesson that you can take on significant figures. And I did this for every chapter. So you can always have stuff to reference, stuff to go over. And if you run into the problem, email me. Just if you don't know why this answer is 0.0249, not 0.02487, email me and ask me. I'm up at weird hours. I don't sleep more than 4 hours at a time. So you can always email me and I'll usually get back to you really quick. So never hesitate to email me at any hours or send me a text message. I'm usually floating around doing something. Okay, but this goes through all the significant digits, the rules for multiplication and division, the rules for adding and subtracting, the rules for rounding numbers. Okay, so it goes through all the rules of significant figures, which we'll go over in this class too. And the next one we'll go over conversions. Tell you how to set up conversions. This is going to have with biology, with nursing program. This is your nursing program. This is what you do. You do conversions. You convert because every drug is given to the patient by mass. You don't give the same dosage to an adult as you give to a 5-year-old kid. It's by weight, and you have to convert everything to weight. And you do the metric system and English system. And this shows you how to do conversions. And we'll go over a lot of that with this course too. Well, what else do I have under density? Density is mass over volume. And this tells you how to calculate density. Okay, these are all free for you to use. They're just things you can review, especially like in your case, what was your first name again? I can't remember it. Hansen?
Hanslin, sir?
Hansen?
Hanslin?
Hanslin. Okay.
Yeah.
You think about to remember that. All right. So in case you're not in tech class yet, these will help you go over and review things. Like I said, review it and then email if you have questions. Okay. The periodic table. This goes over the periodic table, what it means, what everything is, the different elements, metals, non-metals, things like that, covalent compounds, ionic compounds. Okay. These are protons, neutrons, electrons, which we're going to talk about with different elements. Okay. Tells you how to fill out these tables. This tells you number of protons, number of neutrons, number of electrons in an element from the periodic table. And this gives you just an overview of it. Now, a lot of times I tend to talk fast. You probably noticed that already. Once I start talking, I go really fast. So just I usually have to throw something in, but just hit your button, unmute, and just ask me a question anytime. Anytime you have questions, always ask me. I never mind questions. It means you're paying attention if you're asking questions. So I don't mind that at all. Atomic mass, how to calculate from atomic mass, that's a little more advanced. Like we haven't got into that yet, but we will get into that. And here's a review of it right here. Okay, so this is chapter 4, and the same thing. So your modules, we'll go through each one, the chapters, and then all the different help sessions with it. So chapter 2, 4, and 5 gives you your highlights in energy and light, electron configurations, ionic compounds, covalent compounds. So you can look up anything you want. Stoichiometry and limiting reagents, balancing combustion reactions. So all the stuff is here. Ideal gas laws, dilution calculations, everything's here from a textbook. So don't go out and buy a textbook until you know what you need for your class, because everything's here. It's all laid out for you. You go through it. And I'm always available for class. pH calculations, the Chatelier's principle. We'll go over all that stuff. Here's your different organic chemistries. You're going into a nursing program. This is real important. These are your function groups and how they behave in the body. And carbon-14 data. This is a summer class that was kind of condensed, but there's everything on there. Scientific method is just a way of analyzing data. You start with a problem. Okay. You ask questions about it. I'm not very good at that. Says questions. That's a cue. I do a lot better when it comes on that. All right, so you ask a question and you propose a hypothesis. So your first step is a hypothesis, which you hear a lot in different chemistry classes. A hypothesis is an educated guess. Okay, then you test it. You test your hypothesis to see if it works. If it works over and over and over again, it keeps working the same way, then it becomes what's called a theory. That's the scientific method. Like you get up in the morning, like you go to start your car doesn't start. Okay, you make a hypothesis. You say the battery's dead. So you test it. You put jumper cables on it, buy a new, and it still doesn't work. You buy a new battery, still doesn't work. Hypothesis is no good. So then you go back. Okay, after testing. Then let's say you put a new alternate on it. Then it starts. Okay, if it starts continuing over and over and over again, then you have a theory. That is correct theory. Okay, so the difference between hypothesis and a theory is hypothesis is an educated guess, and a theory is a proved scientific fact. Scientific has between 1 and 10. I think I said 0 by mistake. Okay, so we have to make this number between 1 and 10. So where we put the decimal point to make this number between 1 and 10. The decimal point's right here, right? That's what normally is the end of the number. So if we put it here, that number becomes 1,027. Put it here, put it here, put it here. We put it right here, it becomes 1.2703. Okay. Now that number is between 1 and 10, right? Now we've moved the decimal point. So we put times 10, because our numbers are in base 10. And how many places we move the decimal point? we moved it 1, 2, 3, 4 places. So 10 to the 4th. This exponent here tells us how many places we've moved the decimal point. And since this number right here is positive, okay, we moved it to the left from its original place. We've made the numbers smaller. Okay. So if we take our number here, this says times 10 to the 4th, this means it moves the decimal place 4 places. So 1, 2, 3, 4. And that'd be our original number. Okay. So if I had a small number like 0.00375, okay, I'm going to move the decimal point 1, 2, 3 to right there. I'm going to make the number between 1 and 10. So it becomes 3.75 times 10 to the, and how many places I move the decimal point? I move the decimal point 1, 2, I moved it 1, 2, 3 places. Now I made this number bigger, so I have to make this one smaller. So I put a negative sign there. So this one has a negative sign. Because you have to keep the number the same. All we're doing is expressing the number in a different format. We're not changing the number at all. So we're putting it in a different format. Okay, so if we have, I went from this number here to this number here. And in doing this, I made that number larger, right? I went from 0.00375 to 3.75. So I made that bigger. So I have to make my exponent smaller because you can't change your number. In this case, I made the number smaller. I went from 12,703 to 1.27. So then I got to make this whole exponent bigger. If you make it bigger, it's positive. You make it smaller, it's negative. So the positive sign means I move my decimal point 4 places to the right. The negative sign means I move my decimal point 3 places to the left. That's what the plus and minus sign are. So an exponent is just how many places you move the decimal. And sign to notation means to put it in a notation that makes that number between 1 and 10. This is 3.75. And 3 is between 1 and 10. Okay. So if we want to use our exponents, it's going to do it that way. Okay, if we want to use our exponents, let me make some more slides here too. I'm going to run out of slides on this. How do I do this? I'll do it now, like this. I just want to duplicate a couple of these so I have more room to write here. Okay, that should give me some room to write. All right, so let's start off with 1, 2. Oops, what's happened here? This is gone crazy. It's not doing it. There we go. All right, we do it this way. Okay, so let's start up with the number. So I have 12.37. Okay, I want to put that in sign notation. Because I have to, since I have 12, I have to move the decimal point to right there. That'll give me 1.237. Now I move the decimal point 1 place to the left. Have I made my number bigger or smaller?
Smaller?
I made it smaller, right? I went from 12 to 1. So I made that smaller. I have to make this number, my exponent, bigger by 1 times 10 to the 1. Okay. If it's 10 to the 1, you don't put the 1 up there because we assume it's 1. Okay. Any number raised to the 1 power is itself. So 10 to the 1 is 10. Any number raised to the 0 power is 0. Is 1, I'm sorry. So 10 to the 0 power is 1. Any number raised to the 0 power is 1. So this is now assigned to notation. If I had the number 0.0938, okay, do I have to move the decimal point to the left or the right?
To the right?
I'm gonna move to the right. 1, 2 places, right? I got to be between 1 and 10. That's 9.38 between 1 and 10. So it's 9.38 times 10. How many times did I move it? I moved it 1,
2.
2 places. Did I make my number bigger or smaller? I went from 0.09 to 9. So I make that bigger or smaller?
Bigger?
Yep, I made them bigger. So I make this one smaller. So it stays the same. So a negative sign. Make it smaller, you put a negative sign. You make it bigger, you put a positive sign. So I made my number bigger. I got to make my exponent smaller by the same number.
So if
now
it
you
were
know-
to go so if it was to go the other way, it'd be positive. If it was like we went over 1, it'd be to the positive 1 power.
You got it right here. That's exactly what we did.
Oh,
Yep,
Good morning.
perfect. You're exactly right. You made that number smaller. You went from 12 to 1. So you make your exponent bigger, which gives it a positive sign.
okay. Makes
Okay.
sense.
Okay, good. So let's do that. Get rid of those, and we'll do another example here. I actually think it's doing this because I haven't been playing this. There we go. All right, that's back to normal now. Let's say we've got how about 123.783 or 6. And I want to make that number in sign to notation. Now, what do I have to do? Put the number in sign to notation and see if you get the same answer I got. Let me know you guys have finished it, and we'll see if you guys did the same thing I did. Okay. You got it? So you got to remember, you have to be between 1 and 10. So we have to make this number. We have to move the decimal point 1, 2 places to right there. So it becomes 1.23786. Okay, and we move a decimal point. How many places did I move the decimal point?
2.
2 places, right? I moved it 2 places, and then make my number bigger or smaller. I went from 123 to 1.
Smaller.
I made it smaller, make this one bigger, so it's positive. Because what you have to do the exact opposite to keep the number the same. If you make your number smaller, you make your exponent bigger, which is positive. If I make my number bigger, I make my exponent smaller. Okay, to keep the number the same. Yeah.
So scientific notation always has to be between 1 and 10.
Yep.
The number.
Yep. That's it.
Okay.
It's you. I've heard people lecture on this stuff and it's confused me. It does, I mean, they're moving things around going, wait a minute. If you remember the one rule, well, two rules. It has to be between 1 and 10. And if you make the number bigger, you make the exponent smaller, so it's negative. If you make the number smaller, you make the exponent bigger, and it's a positive. That's it. That's all. If you know those things, you put a number in scientific notation. Okay, we used it because Avogadro's number in chemistry, which we're going to use is 6.022 times 10 to the 23rd. Okay, that's 23 zeros. That's how many atoms are in a mole in chemistry. Okay, if you want to write out 6022 and then 23 zeros every time, that's crazy. It doesn't mean anything. You get lost with the numbers. Okay, that's why we use this. We use sanitation because our numbers are so big or so small what we're dealing with, we've got to put it in usable forms. So now we just use this, and then we can multiply or divide by exponents easier. I'll show you how to do that, and as we do multiplication, division, adding, subtracting, different rules and things like that. Okay, so let's take one more example. Let's take a small one. Let's do 0.00009803. All right. Let you work on it for a minute or so, then I'll go over it. And when you're doing this, you practice on it. You want to go over more of it tomorrow or the next day, we'll do it again. This class is strictly for you to understand the basics. There's no tests, there's no timetable. I'm strictly here for you to learn. All right, so let's take a look here. We got to make this between 1 and 10, right? So which way am I going to do my decimal point? Left or right?
Right.
To the right. 1, 2, 3, 4, 5, 6. So it becomes 9.803. This number 9.8 is between 1 and 10. That's how you know where to move the decimal point. Times our factor of 10. Every 10 is just one place. So I've moved it. How many did I move it? 1, 2, 3, 4, 5, 6 places. Times 10 to the 6. And have I made my number bigger or smaller?
Bigger.
Bigger.
Bigger. Perfect. So I make this smaller, which means
A negative.
Yep, that's it. That's all scientific notation is. Okay, so let's do a little bit trickier one now, since everybody's good on that. I don't know if I can erase this or not here. Whoops, what did I do? Now I'll go to a different slide. Okay, so let's leave the top one up. All right, so I was going to keep erasing. Let's take a number. That always works like that. Let's take 127.836 times 10 to the third. Now, let's put that number in sign. That number is not in sign notation. These are numbers we're going to get when we do calculations. We're going to get numbers that have digits and we know with exponents. Now we got to convert this number into sign notation. We already have an exponent, but we still remember the two rules I told you. It will still work every time. We're going to move the decimal to make the number between 1 and 10. So only look at this part right here. Don't worry about the next one yet. Just look at that part. That's 127. That's bigger than 10, right? So how do I move the decimal to make that number between 1 and 10?
You move the decimal over twice.
Got it, to the left.
To the left, yeah.
Yep, 1, 2. Now then it becomes 1.27836. That number is between 1 and 10. Now, times 10 to the 3. Whoa, back up, Stephen. Okay, times 10. Now, we've moved it to the left 2 places. Have I made it bigger or smaller?
Smaller?
Smaller. So make my number bigger. So I'm going to make my exponent bigger by 2, right? So make my number smaller by 2. Make my number bigger by 2. So that becomes 10 to the 5th. Because 3, when we multiply exponents, we add them together. So this is 10 to the 3rd times 10 to the 2nd. And that becomes 10 to the 5th. Okay. And we did this because we moved it 2 places and we made the number smaller, so it has to be bigger. When you multiply exponents, you add. When you divide by exponents, you subtract. Okay? So just remember, when exponents are being multiplied, we just add them together. It's not 10 to the 6th. Don't make that mistake. A lot of students make that mistake. Oh, 10 to the 3rd times 10 to the 2nd is 10 to the 6th. It's not. When you're multiplying exponents, you add them together. So let's take the number 0.372. Okay, times 10 to the 2nd. Okay, so it's a little more complicated when we're doing with exponents, but we still apply the same rules we've been applying. All right, so is that number between 1 and 10? No.
No.
98. So we got to move the decimal to
One
make
to the
it,
left.
I said 9, 10, between 1 and 10, not 9 and 10. So we move the decimal to here, and that'll become 9.8. Oh, I don't want to put these 3 zeros here. But that didn't make any difference, actually, because the decimal is over here. So ignore those 3 zeros in the front. 98.3 times 10 to the 2. Okay, so now it becomes 9.8372 times 10 to the what? You have 10 to the 2, and then 10 to the, we move the decimal 1 place to the left. We made that number smaller by 1, right? 98 to 9. Smaller by 1. So this becomes 10 to the what? This one here.
Positive 1?
Negative 1.
Oh, negative 1. Yeah. Just kidding.
That's okay. No, you're good. That it's confusing at first, so you really got to think about it sometimes. But we made that number, went from 98 to 9.8. We made the number smaller by 1 decimal point.
Okay.
Wait a minute, you're right. It's positive. I was thinking wrong. That becomes a positive 1. We made that smaller, so we're gonna make that number bigger. Oh, I was thinking, I put those 3 zeros, that's what confused me. I shouldn't put those 3 zeros there. All right, what's 10 to the 2 times 10 to the 1 is 10 to the
3?
3, because you add exponents. Perfect. All right, so let's take, I'm gonna end up with, give me another example here. Since I kind of messed that one up. Let's take another number. Let's take, now go 0.0000987 times 10 to the 3rd. Where do I want to end up? Times 10 to the 3. Okay, because when we do our calculation, that's an 8, by the way. When we do our calculation, we're going to end up with numbers like this because we're adding exponents and things like that. Okay. So remember the rules: when you multiply exponents, you add them. When you raise an exponent to another power, then you multiply them. All right, so we're going to move our decimal point to make that number 1, 2, 3, 4. 9.87 times 10 to the something, right? Between 1 and 10, we're at 9.8. So now we got 10 to the third. Let's do it to the side over here. Times 10 to the what? How many places did we move our decimal point? 1, 2, 3, but 4 places, right? I made my number bigger. So that's my exponent, what? Smaller by 4. Okay, everybody see that? I moved to 4 places and I made the number bigger. I went from 0.0009 to 9.87, which is a bigger number. I made it bigger by 4 decimal places. So I got to make my exponent smaller so the number stays the same. If one goes up, one's got to go down to keep it the same number. So now I take 10 to the 3. What's 10 to the 3 times 10 to the negative 4? Add them together. 3 plus a negative 4 is
Negative 1.
Negative 1. You got it. If you're having difficulty adding or subtracting negative numbers, let me know too. We can go over that. Just think of it as a timeline when you're dealing with it. Okay, because we're going to be using these numbers in calculations as we go along. This is just our sign to notation to convert them first. All right, so let me give you guys an example. Let's do 78, 3.926. 3 times 10 to the negative 5. All right, see, we got this as an answer on one of our problems that we did a conversion. And I want my answer in scientific notation because all our textbooks and all the research journals, everything is scientific notation. That's why we do that, to make it everybody standardized. So convert that to scientific notation. I'll give you a minute to work on it and see if we get the same answer. Hopefully we get the same answer. All right. Let's see what everybody got. So we're going to move our decimal, right? We got to make that between 1 and 10. It's 783 now. We got to make that between 1 and 10. So we move our decimal 1, 2 places. So we're going to end with the number 7.839263 times 10 to the whatever we end up with. And we go 10 to the negative 5. And we've moved our decimal places 2 places to the left. We've made the number smaller. So I have to make the exponent bigger. So I moved it 2 places. So it's 10 to the 2. So I take 10 to the negative 5 times 10 to the 2. Okay, add those together. Negative 5 plus 2 is?
Negative 3.
Perfect, negative 3. That's it. You guys are expert at scientific notation now. So we put any number in scientific notation, which is what we use when we do our data. Okay. We'll learn how to round off those numbers and express them in different things as we go later on with significant digits as we go through the thing. So this covers scientific notation. So any questions on scientific notation? Okay. I'm sure more will come up as we start using it. All right, we're going to go through units also here. Units are how we measure something. Okay. We measure mass in grams or kilograms or pounds in our system. Metric says we use grams. Length. We can measure miles, inches. Most of the time we use meters for the metric system. Okay. America is one of the only countries that still uses the standard system. Most other countries are all in the metric system. Okay. Metric system is easy because it's all by powers of 10. It's all by your exponents. So it converts everything. But mass is just how much something occupies in a certain space. Its mass is going to be the same no matter where you're at, the Earth, the moon, whatever. Your weight is going to be different. Weight is how much you're attracted by pulling gravity on that mass. But as long as you're dealing with things on Earth, which usually are mass and weight are the same number. Okay. So if you change gravitational pull, then you change your mass and weight. But mass is used in grams, length is in meters, time is in seconds. Okay, that's the same for European countries and us. And temperature is in Kelvin. Okay. We use Kelvin because a lot of our calculations can't have negative values. Okay, because you can't have negative things. So Kelvin temperature can never have a negative value. We explained before. It's not a degree Kelvin. Kelvin is a measurement of motion, of movement. And it's our temperature scale. It converts from our temperature scale. Okay, at 0 Kelvin, all movement stops. You can't go below that. Okay, and we're able to convert, we try to convert between Kelvin and centigrade and Fahrenheit, things like that. Okay, but these are the units we use where we're dealing with, these are the units used when we're dealing with measuring, with dimensions. We have grams, meters, seconds, and Kelvin. This is what we use for our measurements. Now we put prefixes in front of those. This is a metric system. Metric system just puts a prefix in front of your units. Like say we had milligrams. Milli in the metric system is 10 to the negative 3 grams. Okay, 0.001 grams. You the decimal point 3 places to the left. Okay, so for the metric system, if you look on my data sheet, it gives you all the conversions. Okay, for the conversions, we'll put, let's get another slide here. Mega, the capital M, is 10 to the 6. You multiply that number by 10 to the 6 for mega. Kilo, which you've all heard in dealing with cocaine busts from the United States, I think everything's measured in kilos. Kilo is 10 to the 3. You can see a K in front of it. Okay. A kilogram is basically 2.2 pounds. We do with our English conversion. These are the common ones. Centimeter, a centi is 10 to the minus 2. Milli, we talked about, was 10 to the minus 3. We'll cover the ones. Micro is 10 to the minus 6, and nano is 10 to the minus 9. Those are the basic metric values. Like I said, those are your data packet. They're in any book, but those are ones that we use. Just be careful, because a capital M is 10 to the 6. A small m is 10 to the negative 3. And then this mu here, this is the Greek letter mu right here. That's the Greek letter mu. It's got like a U with a little tail in the front of it. And that's 10 to the minus 6. So mega is 10 to the 6. Kilo is 10 to the 3. Centi is 10 to the negative 2. Milli is 10 to the negative 3. Micro is 10 to the minus 6. And nano is 10 to the minus 9. So if you're dealing with like a camera shutter speed, if you do sports photography, okay, you want that shutter to capture the action. You don't want it to have a big open field, like everything gets blurred. Like the camera I use has a 2.75 nanosecond release. So take place 0.00009 zeros, 275 a second. It's really fast. So this is a nanosecond. When you have an N in front of something, it means 10 to the minus 9. So this is 2.75 times 10 to the minus 9 seconds. Okay, that's all that means. All that number means there, that letter, is just a value of an exponent. So if I'm measuring out something in a chemistry lab and I have to measure out 35.8 milligrams. Okay, that's the same as measuring out 35.8 times 10 to the negative 3 grams. Milli just means 10 to the minus 3, when this number is in front of one of our units. And I can put milli in front of grams. I can put it in front of seconds. I can put it in front of meters. Okay, so any of my units I can place milli in front of. And it's just an exponent that expresses the value. And we're going to use this a lot in conversions. So if you understand, instead of writing mega, I can write 10 to the 6. It's the same thing. Okay. If we make, if the cops make a bust of 3.98 kilograms of say heroin, okay, that's 3.98 times 10 to the 3 grams. This K just stands for a value in the metric system. That's all it is to our base unit of grams. Okay, that's become real important doing conversions. But that's how we record units. So these are the, there's other ones. There's what's happening again? Zilla, Bazillia. There's other ones out there. These are the common ones. Mega, kilo. There's decimeter. There's other ones like that. But mega's 10 to the 6, kilos 10 to the 3, centis 10 to the minus 2, millis 10 to the minus 3, micros 10 to the minus 6, and nanos 10 to the minus 9. Okay, those are the common ones you're going to deal with. The other ones you can look up too. Okay. Now, when we're doing these, okay, so everybody understand this is your metric system. Okay, and we have conversions to convert between the metric system and how we do it in America. Okay. So like I told you, like there's 1 kilogram is 1,000 grams, 10 to the 3rd grams is equal to 2.205 pounds. So a 200-pound person is going to weigh less than 100 kilograms. Okay. If we have 1 inch, erase all that. Just skip the next page. Maybe skip the next page. Computer's slow here. Okay, so say I have 1. I'm still erasing stuff. Okay. So I have 1 inch, 1.00 inches is equal to 2.54 centimeters. That's a conversion. And that's on your data table, data packet. We convert different things, like 3 feet is a yard, 12 inches is a foot, 1 inch is 2.54 centimeters. That allows us to go from the English system of measurements to the metric system. Because when you do any kind of papers, any kind of publication, any kind of work, is all going to be in the metric system. Okay. And different conversions. Now we do conversions. There's one key one that is not listed anywhere. I think it's in your data packet though. It's a cubic centimeter is equal to a milliliter. And we'll use that when we start doing our conversions. It's not it allows you to go from measuring something like with a ruler to volume. Remember, meters are just a number. Area is squared. volume is cubed. So volume is 3 measurements, length times width times height. Area is 2 measurements, length times width. And then the normal measurement is just 1 length, like meters. Okay. So we have our regular measurements. Then we have our area, which is squared, and our meters, which is cubed, because it takes 3 measurements. And if we measure it and we get all 3 measurements, we get a cubic meter, a centimeter cubed. That's equal to a milliliter. And milliliter goes to our volume. Like a graduate, so we can measure out milliliters. So we get a measurement from that. That's a neat conversion to be able to remember. All right, so we got all that. Just make sure we covered all the conversions. Yeah, we did all that. Pretty good. We'll get to conversions a little bit too. So let's talk about what those numbers mean as far as uncertainty in our measurements. Okay. Significant figures. When you measure something, you can only measure something to a certain accuracy. Okay. Say you take a ruler and you say you measure something that's 1.2 inches. Like 2's not very good. Okay, so we have that ruler measure like 1.2 inches. Can I say that's 1.203965 inches? I can't say that, right? I'm not accurate to that. I can't see the ruler that accurate to make that number. You can only measure things to what's called significant figures. Okay? Significant figures are only what we can get. If you take a measurement of, say you weigh yourself, okay? Say the scale says 123.4 pounds when you weigh yourself in the morning. Okay, you cannot say that's 123.409785 pounds. Okay, you're not that accurate. Now, if you get an accurate enough scale or a balance, you can do that. Okay, but accuracy is determined by how you do your measurement. You can't make something more accurate than it is. You can't just add numbers. There's a big difference between 123 and 123.000. Okay, now, normally in math, that's the same number. But in science, that's a whole different number. Because you're telling me that tens, hundreds, thousands, that you're measuring to this accuracy. You know that number is 0. You don't know it's a 2 or 3 or 4. You know it's 0. You've measured that accurately. So you can't just add zeros after a decimal point, because that determines accuracy. You see why this and this are not the same number. They're the same value, but they're not the same number because we don't know these values. We only put those if we know those values that we measure to. You can only measure to a certain amount. Okay, so that's your what's called significant figures. Okay. And we use those when we do calculations. You can't, the big thing is you can't make your data more accurate by using math. Okay? You can't make something more accurate. So we have rules of how we use these significant digits. So let's say, first we got to determine how to determine significant digits. So let's determine significant digits. So if you have a number that says 378, that has 3 significant digits. All those numbers are significant. Okay, all digits are significant. If we had 37008, we have 1, 2, 3, 4, 5 significant digits. Okay, all those numbers are significant. Zeros are significant when they're in between digits. Okay, if I had the number 64,000, we have 2 significant digits. Zeros are not significant at the end of the number. They're placeholders unless there's a decimal point. Once there's a decimal point, then zeros are significant because we've measured to that point. This is just a placeholder. Now, if I put 64,000.1, how many significant digits do I have now? That's going to have 6 significant digits. Once you have a decimal point, those zeros become significant. They're not just placeholders anymore. You've got a measurement to this value. You know that number. If I put on 64,000.0, I have 6 significant digits still. The only reason that 0 is there is because I know it's accurate. I know I've measured to that amount. I know that 0 is significant. Or else, why is it there? Doesn't change the value any. But that has 6 significant digits. And we're going to use these in a little bit here too, in doing calculations. Zeros before a number are insignificant. They're placeholders. 0.000000923 has how many significant digits? We have 3. These are the only significant digits. All the rest are placeholders. An easy way to do this is put the number in scientific notation. It'll tell you. Scientific notation, this becomes 9.23. We're talking about significant digits. Yeah. All right, so when you're using the digits, you use that in the numbers to determine how to express a number. I mean, when you add numbers together or multiply together, you can't get an answer that makes the number more accurate than the data you put in. You can't make things more accurate with math than your measurements. It's why we have to have significant digits and the rules for doing this. So we have 2 sets of rules. Rules for addition and adding and subtracting, and rules for multiplication and division. Okay. When we're adding and subtracting, when you add and subtract, it's the least accurate number for your answer. Okay. The answer can only be expressed to the digit that is the least accurate for any number. Say we're going to add 1.36, 2.05, 3.7. So we're going to add those together. Okay. 11, 4, 11, 2, 4, 7.11. If you put 7.11, you get it wrong. Because what you've done, this number, remember, this is only for adding, subtracting. This number is good to 2 places past the decimal. This number is good to 2 places past the decimal. This number is good to 1 place past the decimal. Your answer can only be as accurate as the least accurate number. So your answer can only have 1 place past the decimal. So in this case, it'd be 7.1 would be the correct answer. That's what I mean by you can't make a number more accurate by mathematical manipulations. That's not allowed. It's only as accurate as you measured it. Now, when we're rounding numbers off, okay, this was a 1 here. We round it off. This number is less than 5. This number stays a 1 right here. Okay. If this number is 5 or greater, it becomes 7.2. So if it's less than 5, it rounds to the lower number. If it's 5 or greater, it rounds to the upper number. Okay, so the answer here would be 7.1. If we had, let's add 1.001 plus 0.89 minus 0.37. Okay, so rather than do that, let's get my calculator and we'll calculate up, make it easy. We have 1.001 plus 0.89 minus 0.37. And the calculator comes out with 1.521. Okay, that's the answer you get on your calculator. Now, is that the right answer? It's not the right answer, but
So if you round it, it would be 1.52.
yep, 1.52 is the correct answer. Because this is good to 3 places past the decimal. That's good to 2 places past the decimal. That's good to 2 places past the decimal. The least accurate number is where you have to round to. You can't go more accurate than that. And this is less than 5, so it stays at the lower number. Okay, so let's do one more. Let's do 20. That's plus, this minus. It's a 2. All right, so let's take, wow, what happened? No, it's here somewhere. Here it is. There it was. Wait a minute, what happened to all these numbers? Let's hit play. Oh, I have to do it again. Okay. Let's take, what did I say, 100.07 plus 18.382 minus 28.3927 plus 11.39. Okay, add those together. So just see on your calculator, you would hit 100.07 and then plus 18.382 minus 28.3927 plus 11.39. And it equals, and it comes out to 101.4493. Okay. If you put that answer, you would get it wrong. Because what would that, what would be the correct answer for that equation?
Would it be 101.45?
Exactly what it would be. Perfect. You're only good to 2 places past the decimal. This number here is greater than 5, so it becomes 101.45. That's how we round. Okay, so that's adding and subtracting. Multiplying the division. we have another set of rules. Okay. Multiplying and division, it is the number with the least number of significant digits or significant figures. So when you're multiplying them, you look at each number and you find out which one has the lowest number of significant digits. So if I take 9.73 times 14.2 times 0.032. Okay. I did it on my calculator. I'd say 89.73 times 14.2 times 0.032. That comes out to on the calculator, it's 40.773312. Okay. Now that can't be right because they're not accurate. So the first number has how many significant digits?
5.
4. 89.73 has 4, right? 89.73. 4 digits.
Yes.
Okay, the second one has how many?
3.
3. And the third one is how many?
Would it be 2?
Yep, exactly right. So when we do multiplying division, we take the number with the least amount of significant digits. So our answer can only have 2 significant digits. So we go 2 digits on our number, put a little line, I always put a little line there. And that becomes what? You look at this number to see what happens. Your answer is?
Is it just 40?
41, because this number here is bigger than 5. So that rounds it up. Okay, so if that number is less than 5, it goes down or to the lower number. If it's 5 or greater, it goes up to the larger number. So the answer becomes 41. Okay. All right, let's do another one of those. Let's take 111.82 times 98.6 divided by 801 and 35.937. Okay, there's your math problem. Now, another rule in doing problems like this, if the number's on top, you hit multiply. If the number's on the bottom, you hit divide. I know it sounds simple, but most students will get this wrong. I guarantee you, your first chemistry test, 60% of the class didn't get that question wrong. It's just like that. They'll do 111.82 times 98.6 divided by 801 times 35.937. Give the wrong answer. It's cumulative. There's properties of multiplication. What you would do on the calculator, just remember this, don't use parentheses or anything like that. Just keep it really simple. If it's on the top, you're going to multiply. If it's on the bottom, you hit divide. So for this answer, you would hit 1182 times 98.6, divide 801, divide 35.937. So it's on the top, you multiply, the bottom, you divide, and you'll never get it wrong. Just keep it real simple. Follow that simple rule. So we have got 111.82, 111.82 times 98.6, divide 801, divide 35.937. Okay, and that comes out to And you should work the calculator too if you have one there with you. 38302054. Okay. That's what you get on the calculator. Is that what you got? Perfect. So this is our answer. How many significant digits can our answer have? Let's look at our numbers. The first number has 5 significant digits. The second number has 3. The bottom number in the first one has 3, and the top one and the bottom number here on last one here has 5. So we can only go by the least number of significant digits. So our answer can only have 3 significant digits. So look at our number, our answer. 0 is a placeholder. There's just, we have 3 digits up to this point right here, right? That gives us 3 digits, 3 digits. So our answer would be 0.383, because this number here is less than 5, so it stays the lower number. So this number here stays your lower number. Okay. Let's do another one like that. Let's do. Okay. Let me know what you get. I'll do it. And you tell me what you get too. 938. All right. What do you get when you multiply them when you calculate?
I got 287.04044684.
Perfect. 287.040468. I can try to sign it, get a little bit more numbers. Holy cow, 683718. It keeps going. We'll just leave it at that for now. All right. So round it off. How many single digits can your answer have? This has 4. This has 2. This has 3. And this has 5. So how many significant digits can your answer have?
2.
2. Perfect. So draw a line. Oh, I hit something again and made it go away. Gosh, darn it. I don't know how it does this on this. It keeps messing up. All right, so it was, what was the number again?
It was 287.040468.
Okay. So this is where you'd have to have your digits. Okay, so what would your answer be?
Well, so it only has 2 significant figures.
Right?
So would it be 28? But then the number next to it is a 7, so I don't know.
Okay, 7 is bigger than 5, right?
29?
If that number is bigger than 5, it rounds this number up. Okay, so what would it be?
29?
29 has 2 single digits, but remember, You're saying 287 rounds off to 29? That doesn't make sense, right? Okay. You gotta have your placeholders. You have 3 digits there before the decimal. So 287, that's 7 is bigger than 5, that rounds up to 9. So then it rounds up to 290. Now the 0 is not significant, so you still want to have 2 significant digits in your answer. But you gotta have that as a placeholder. Because if you loan someone $287, you can't round it to 29 when they pay you back. Right? You're at 290. So you gotta watch when you're rounding things. You gotta make sure you keep your digits as placeholders. Because let's round off a couple numbers here. Let's say 643.978. Round that off to 4 significant digits. What do you get? So take this number here, round it off to 4 significant digits. Okay. You'd count 4 digits, 1, 2, 3, 4. So I always do, I draw a line at 4 significant digits. Then I look at this number right here. Is that number bigger than or 5 or greater?
Greater.
It's greater than 5, right? So that means this number, the number here, is going to round up. Now 9 rounds up to 10, right? So this becomes 640, and then this rounds up to 10, so it's 4.0. Because the 30 now rounds up to 40. So you gotta remember, this rounds up, it makes this one increase by 1 also. If it rounds down, it would keep the 9. Okay, so that'd be 644.0 before 7 digits when you're rounding. If you have 7, 8. Okay, round that to 4 digits.
So would it be 718.6?
Yep, exactly, because this is 5 or greater. So 718.6. Perfect. So we know significant digits, that's good. And we round it off. All right, so let's do some calculations. Okay, let's use our exponents now. So say we have the numbers. Okay, let's multiply those 2 numbers together. So the question might be to multiply those numbers and put your answer in scientific notation. Okay, easiest way to do this. Do the digits first, then do your exponents. So let's take 8.93 times 6.024. So you want your calculator. Why is it not? Oh, it's upside down. That's why the thing's not working. So 8.93 times 6.024. That comes out to 53.79432. Okay. And then it's going to be times. Then we do our exponents. So there's our number. We got from the calculator. And then remember, we multiply exponents, we add. So -6 plus 8 comes out to what?
2.
2 times 10 to the 2. So there's your answer. But it's not assigned to notation. And it's not rounded off. So let's round our number off. How many significant digits are we good to?
Is it 2?
This number has 3. This number has 4. So we're good to 3, right? 3 significant digits. The least number of significant digits, how accurate the number is. So the number becomes, you have to have 3 significant digits. So I draw a line right there. Okay. What does that round off to in 3 significant digits?
53.8.
Perfect. So you have 53.8 times 10 to the 2. And they're still not significant figures. I mean, sign notation. So you gotta make this number between 1 and 10. So you gotta move the decimal point one place. So it has to be 5.38 times 10 to the, and we have 10 to the 2. And I move that decimal point one place. I made my number smaller. So I get my number bigger by 1. 10 to the 1. 10 to the 2, 10 to the 2 times 10 to the 1 is 10 to the 3rd. So this is your answer in assigned notation. So do the digits first, then go back and do your exponents, round it off, and put in assigned notation if they want assigned notation. Okay. All right. Let's do a bigger one here. Let's do 3.0896 times 10 to the 6 times 9.56 times 10 to the 4th divided by 3.02 times 10 to the -3 and 6.8972 times 10 to the 10th. All right. Let's do those over. Let's do the calculator. We're going to do everything except for the exponents at first. 3.0896. Okay, what'd you get for doing the exponent, the digits?
I got 124.5300702.
Perfect. Okay, there's our number there. And then times 10 to the what? Now, when you're dealing with exponents, when they're on the bottom, you bring them up. So we have got, and change the sign. So we have 10 to the 6 times 10 to the 4th. Those are the top two, right? Then we bring this one up and we change the sign. So times 10 to the 3, bring this one up and we change the sign. Times 10 to the -10. So within the bottom, that's a lot clearer than that. When they're on the bottom, you bring them up and change the sign. So you got 10 10 to the 6, 10 to the 4, 10 to the 3, and 10 to the negative 10. And add all those together. Comes out to 10 to the what?
Is it 3?
Yep, exactly. Perfect. Okay, so there's your answer. Now we've got to use significant figures. So what number has the least amount of significant figures?
3.02?
Perfect. And how many is that?
3?
Very good. So we have to stop it right here. And this number is larger than 5, right? It's 53007. So what do we do to this number right here?
Round it
To upper down.
up. So
Yep,
it'd be
that's big. So it becomes 125 times 10 to the third. Is your answer. Okay, makes sense?
yes.
Okay, we'll do one more, then we'll, let's go a little early here, unless you have any questions. So let's do. And divided by. Okay. Let's do this, see what we get. 883.21. All right, what do you get for your value, your numbers?
I got 260.633763.
Very good, perfect. All right, now those are numbers, now do our exponents. So let's look at our exponents. We got that one, that one, that one, and that one. So we got 10 to the negative 6 times 10 to the third, and we bring that up and change the sign. Oh, downstairs, I won't leave it here. 10 to the negative, and then 10 to the 8, thank you. And 10 to the negative 2. Okay. So we add those together, the -6 and 3, and then we, from the bottom, we bring them up, change the sign, so 10 to 8, and then 10 to the negative 2. So this becomes times 10 to the, we got -6, 3, 8, -2.
No, I got 3.
6, -3 is 5. 5 minus 2 is 3, yep. 10 to the third. And how many significant digits in our answer?
4.
Yep, we got it. So we'll round off right here. So our answer would be, does this round up or down right here?
Down.
Yep, goes to the 6, goes to the lower one, because it's less than 5. So 260.6 times 10 to the third. There's your answer.